Hi guys, so in the last few weeks we have mostly been busy with repairing inverters which were installed in my AC-coupled DIY Powerwall, but in general we did not take a look what else have been done. And at the Powerwall actually there have been a few changes, and today I want to show you what I have upgraded. And yeah, it's probably been some of the last steps which I can do, and everything is working quite nice here anyways. So let me show you what has been done here. So this here is my AC Powerwall, and at this time of the year it's covered in blooms from this tree. This project is now existing for around 5 years. The Powerwall in general is recapturing around 4 megawatt hours of electricity per year, and then putting back into our AC grid here during the nighttime. Yeah, what has been changed the last few months? You know, we had a problem with the polarized DC breakers. These have now been replaced by non-polarized breakers. Biggest difference change which was made here is now this guy here. You can remember I already have one here. This is a variable charger. So on this place there has been a 15 amp constant output charger installed. I am taking my electricity from 2 phases, and yeah, so phase 3 actually had 2 constant amperage chargers, and this is the other phase. Phase 1 had 1 variable plus 1 constant. So I have now replaced one of the constant, a small one, by a variable charger. So now I can also on this phase, this is instead of the 15 amps now a 5 to 25 amp variable charger, and this is really great. I will show you later on a graph where you can see how this works out now. I can keep my system here almost out of any excess going out to the grid. Yeah, there was no changes with the cells, of course. They are slowly degrading. You can watch them how they do this. So these are used cells. Originally these cells had 30 kilowatt hours capacity. Of course, when they have been brand new, at the moment only around 16 kilowatt hours are left of life inside them. Okay, and the third thing I have changed here, you might have remembered here was a current shunt, and I used a shunt sensor here, a DIY sensor, to measure my current. But unfortunately this sort of setup, you know, 4 chargers, 3 inverters, every one of these devices cutting into the DC, creating ripples, creating noise, etc. This was not working with the shunt sensor anymore. I had to compensate every possible way with the microcontroller, and it did not work also anymore because the measurements have been differently distorted during charging, during discharging. There was no logical possible way anymore to get some really reliable data from the current sensor. That's why I have changed it to this now. So this is a Hall sensor. Some might know it. I think it's the ACS 758. This is a 100 amp sensor, bidirectional, and it is actually quite nice. This board here, it's a finished board with nice terminals, etc. It has some special features here which I don't need in this case. It's a quite, for AliExpress, for a Chinese product, even expensive board. But this one works. It is showing really nice current data for charging, in this charging. Albeit I had to hack it a little bit. I had to replace a capacitor here on the low pass filter also for this, on the noise filter of this board. And yeah, with this it's okay for the moment, but still I had an idea. I actually will make my own one. Who's watching my channel knows I'm taking some Chinese cheap products and improving them and selling them then as well. So yeah, the next project is an improved current sensor. I will make a video about it, and anyway show you exactly what this one can do and what I don't like on this one, and then what I will make by myself and what this will do better, why it will be improved, and if somebody is interested and can also purchase a board of that. It will be actually cheaper, my board, than this one here. So yeah, how does this work with my chargers here? I'm removing excess energy which is measured in my MDB here, main distribution board, from the controller here, and the controller is then telling the chargers which one have to turn on, right? And in this case also how much of energy they have to remove by setting the charger with a digital potentiometer. I'm removing energy from two phases, right? It's the phases where I have the big arrays on, and yeah, this is phase 1 and phase 3, and each of the phases have one constant output charger now. This is a 20 amp one, this is 25 amp one, and now one of the variable output chargers, so 5 to 25 amp. So every time when I have excess energy available, initially the variable charger will follow the output, and then when there is more than the variable charger can remove, then it will switch on a constant output charger, and the variable can then start again from the low output side going up again, right? All this is controlled via the DIY digital potentiometer. I had to make a adapter board. You can see that also in a video. This adapter board can set a upper limit of the charger, because these chargers, interestingly, they say they're advertised with 25 amps maximum, but they actually can go up to 31 amps. But I don't want this in my climate, hot and humid, so I have set the upper limit here via my adapter board to 25 amps. Yeah, like this. I can now actually follow the excess up to 2,500 watts of variable power. This is quite a lot. Yeah, and this is now the graph which I told you before. I will show you how the Powerwall is now counteracting excess energy. And with those two variable chargers, if you look here, we have the zero line in red, we have the actual power during the day, then we have the maybe theoretical solar curve, available energy curve given by the solar. And all this here is missing, and you can see how closely the total power is tracking the zero line. Until here, of course, at the end the battery was then full, and then the excess power had to go to the grid. Yeah, that is really a fantastic result. This is almost a feeling like you have an industrial product like a Tesla Powerwall or whatever. This is behaving exactly the same way, and is a DIY project for the fraction of a cost. So yeah, that's the AC Powerwall. Everything is working perfectly. So the next mini project will be building a really good DIY current sensor, and after that the system as it is set now is kind of finished. So that's it. That were the newest, latest upgrades. The story about the current sensor will follow. We will maybe look a little bit into signals, into the problems. Okay, so thank you very much. This was just a short update. I hope you found it interesting. Please like, comment, subscribe to the channel, and I see you next time.